In problem 1, we are going to be looking at the difference between linear functions and exponential functions. So for part A, we're asked to complete the input-output table for each of the functions below and then graph each function on the grid provided. So for the second column here, f of 0, 2 times 0 equals 0. 2 times 1 equals 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. And 2 times 5 is 10. So this is a classic linear function. For function g of x is a little bit different. The input is in the exponent value. So let's see what's going to happen there. So g of 0, that's going to be 2 to the 0, and that equals 1. G to the 1, 2 to the 1, and that equals 2. So 2 squared is 4. 2 to the third is 8. 2 to the fourth, 16. And 2 to the fifth equals 32. So go ahead and pause the video and then plot each of the sets of ordered pairs on this grid and connect them to see the shape of these graphs. Then start the video again and check your result. So if you notice on the graph here, f of x is our linear equation. Looks like what we're used to. G of x is a different kind of equation. This is actually called an exponential equation or exponential function. So notice how it starts off a little bit higher than f of x and how it grows slowly at the beginning and then all of a sudden it just shoots up like crazy. This is called a J-curve. And you'll see this shape as a very distinctive shape associated with exponential functions. So for part B, what do you notice about the outputs in the table above and the graphs for each function? So as far as the graphs, f of x we can see is linear and g of x is exponential. So we can say that about the graphs. And then as far as the outputs for f of x, we add 2 to move from one output to the next. So there's our additive process again for a linear function. For g of x, if you notice, what happens is we multiply. So to get from one output to the next, we multiply by 2. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So for g of x, we multiply by 2 to move from one output to the next.